today we're going to go over lesson 13. Last time during class I talked about how when we're using completing the square, it wasn't going to necessarily make sense as to why we were doing it. The reason is because we were just practicing the skill last time, learning how to complete the square and work with different things. This time we're going to be completing the square and using it to solve. So with these, especially when we get down to some of these like this, completing the square is going to help us to solve without having to factor. And sometimes when you can't factor it, the way we've been working on, you can use completing the square to find an answer, find a number that'll work. Next time we'll go over a way that you can use without completing the square. But for today, this is what we're going to do, is solving with completing the square. So the opening exercise here, I want you to practice these on your own. This is just going to be solving the equation for b. You should be able to factor it. And then this one down here, rewrite the expression by completing the square. So I want you to practice with these two, and then we'll come back and work on it. Okay, for the first one here, for A, I just went ahead and solved it for you, and I'll kind of walk you through the steps on how to solve this one. So the first thing to do is to move everything to one side. It'll probably be easier just by looking at 2b squared and 3b squared. They're both positive, but it's easier to work with a positive b squared. It doesn't really matter what the rest of it is, but it's easier to work if this one is going to be a positive number. So we'll subtract 2b squared from each side, and then we'll also do that with this 9b. We'll add 9b to each side. That way then this side is going to become 0, and then we can add on to this side. So you get b squared plus 5b minus 14. So then you're going to factor this out. Our factors of negative 14 are going to be 7 and 2, 1 has to be negative, and then also 14 and 1. So when we add them together, 7 and negative 2 are going to be the numbers that will work. So it'll be b plus 7 and b minus 2. So then the next thing is splitting it up. So you have b plus 7 equals 0 or b minus 2 equals 0. So for this one to solve, we subtract 7 from each side. We get b equals negative 7, or for this one we'll add 2 to each side, so it's b equals 2. For the next one here, rewrite the expression by completing the square. First thing I do is just rewrite it out. So you have 1/2 b squared, it's going to be minus 4b, and then this plus 13, we'll push that off to the side. Then we'll put that in parentheses. So we're going to have to distribute out a 1/2. So that we can get this to be a positive. So we'll have 1/2, and then on the inside here, we're now going to have, it'll be b squared, and it'll be minus, and we'll do negative 4 divided by 1/2. So when you do that, it's the same as saying multiplying by 2. So this one's going to become 8b, and then we have the empty space, plus 13. So to figure out what we need to work with here, we can set up a box. So that we're going to have b squared in one of them. We'll split up this negative 8b in half, so negative 4b, and then we'll use the box to figure out what this last term will be. So b and b, when they're multiplied together, will give us b squared. So when we look at, okay, b times what will give us negative 4b. And in this case, it's going to be negative 4. And we'll do the same on the other side. And again, it's negative 4. So then to figure out what this number is here, we're going to take negative 4 times negative 4, and we get 16. So we add 16 on the inside. Now, when we're figuring out what we need to subtract from the outside, we're going to have to do 16 times 1/2, because we technically added 8, which is what 16 times 1/2 is. So we'll subtract 8 on the outside. So to finish this, we have 1/2. If you use the box, you already have the factors, b minus 4, b minus 4. So b minus 4 squared. And then we do 13 minus 8, so we have plus 5. So that's what we would have for that one, completing the square and working with that. So now in example 1, we're going to see how we can solve using this. So for this one here, it says solve for x. In the past, what we would do here is we try and you could factor it out. You normally subtract the 12 over and work with that. But for this time, we're going to do something a little different. We're going to use completing the square. So we have 12 is going to equal x squared plus 6x. and then we're going to figure out what this c term is going to be. So the way we do this, again, we can create the box. We have x squared. Half of 6x is going to be 3x and 3x. And then we'll work to figure out what this last term is. So we have x and x. X times x gives x squared. If we do x times 3, we're going to get 3x. So it's a positive 3. And then x times the 3 here will give us the 3x here as well. So then, to figure out what this missing term is, we do 3 times 3, and we'll find out it's 9. So for this one here, we'd say plus 9. And when we do to one side, if it's an equal sign, we do to the other side. So it's 9 plus 12. And then we can work with our squared. So we'll end up getting x plus 3 squared. So that's what we'll get on these two sides. And then that's going to equal 21. So then from here, we can square root. So we'll square root each side. So we get plus or minus the square root of 21. We don't know what that is. It's not a nice one, so we'll just leave it. And that's going to equal x plus 3. So the final step in solving is to subtract 3 from each side. So I'm just going to write it off to the side over here. We're going to have 3, or negative 3, plus or minus square root of 21, and that'll equal x. And that's where we would stop. So as you can see, this isn't going to be a nice number. The square root of 21, it's not a rational number, so it's not one that we can easily factor with the methods we've been using before. So now this completing the square will help us to solve using different methods. So the next part here talks about rational and irrational numbers. So for here it says the sum or product of two rational numbers is always a rational number. The sum of a rational number and an irrational number are always an irrational number. And the product of a rational number and irrational number is not 0. So what this is saying, if you aren't really sure what a rational number is, so a rational number is one with a decimal that will stop or it repeats. So it can be represented with a fraction. With a fraction or the decimal that's repeating. So 5 over 16, that is a rational number. 22 over 7, rational number. Anything like that would be a rational number. So an irrational number is one that just keeps on going and there's never a rhyme or reason to it. The numbers don't repeat. So it cannot be represented by a fraction. So an example of this would be pi. Pi is an irrational number. Even though we can shorten it to be 3.14, it actually keeps on going for quite a long time. And sometimes we represent with a fraction as 22 over 7. Again, that is not necessarily a rational number. We shorten it so that we can use it, but it's not a rational number. Another number that would work is like the square root of 21. That's an irrational number. This one will keep on going, and it's not gonna ever break or repeat or anything like that. So irrational numbers, you cannot represent with a fraction. So square root of 21 would be an example. If you want to do the square root of 3, that would be another example. Those numbers cannot be represented with a fraction. And they don't stop, they don't repeat, anything like that. So just a little bit of vocabulary there for you. So example 2, and we're going to solve for x. So on this one here, this one is a lot like what we had last time in lesson 12. So the first step, I would subtract 94 from each side. Just so it's on the other side, we don't have to worry about it. So we have 4x squared minus 40x equals negative 94. So the next thing here, we don't like this first number being anything other than 1. So we need to divide out 4 from each of these. So we'll divide out 4. 4, and we had x squared minus 10x equals negative 94. Okay, the next thing we can do, or we're going to do, is we're going to complete the square. So when we work with this, we have x squared, we'll use the box. So then half of negative 10 is going to be negative 5x, so negative 5x. Then on this one, we're going to have x and x. And then for these two here, x times negative 5 will give us negative 5x. X times negative 5 will give us negative 5x. And then we'll multiply these two together to get our missing term. So it's going to be plus 25. So we'll have 4x squared minus 10x plus 25. That's going to equal a negative 94. So at this point, we still have to remember that this needs to be added to the other side. But we have to do over 4. So it's going to be plus 25 over 4. The better option, though, instead, is before we even get to this point, before we even get to adding 25, is to divide by 4. That way, we get rid of this, and then we're left with x squared minus 10x plus 25 equals negative 94 over 4 plus 25. That way we can work with that. So the next thing here, get this into our factored form. It's going to be x minus 5 squared, and that's going to equal, so this would be 100. So if we were to put this 25 into a fraction, it would be the same as 100 over 4. So it would be 100 over 4 minus 94 over 4. So when we do that, we'll end up getting 6 over 4. So we get 3 over 2 as a reduced form. We can divide each of those by 2. So we get 3 over 2. And then our next step here, square root each side. So x minus 5 is going to equal the square root of 3 over 2. And then to finish it, I'm going to bring this over to the side. We're going to add 5 to each side. Do not forget that that's plus or minus either. So it's going to be x equals plus or minus the square root of 3 over 2 plus 5. And so that'll be our answer. That's what we'll leave it as. So just make sure that you realize that that square root goes over the 3 and the 2. The main reason we're solving this way is once we get down to this, then we can square root each side. You don't want to have the 4 over here before you square root. So we don't want this 4 over here. It's going to cause kind of a headache to work with it that way. It's just better if we can get all of our numbers on one side, get down to our square root, and then finish solving with that. So I want you to practice with 1, 2, 3, and 4. Practice with those, and then I will help you with them when you're done with them. Okay, number 1, I worked it out completely just to save on some time. So the first thing I did here was I rewrote it out, and originally I didn't have that plus 1 in there. I just rewrote it back out and left a little bit of space. So the nice thing here, you don't have to do anything to this one. You don't have to move anything or divide anything out. So we can just put these into our square. So you have x squared, x, and then we'll have minus 1 and minus 1. Because it's a negative 1x, negative 1x. So x times negative 1, that works out. X times negative 1, that works. And then negative 1 times negative 1 is going to give us 1. So then we're going to add 1 to this side. And what we do to one side of the equal sign, we have to do the other. So it's plus 1 over here. So then I wrote it out in factored form, x minus 1, and it was squared. And then I also had 13 on the other side. So I square rooted each side. Then the next step, you get x minus 1, that's going to equal a plus or minus square root of 13. You add 1 to each side, and then that's your answer. X equals plus or minus the square root of 13 plus 1. So that would be the answer that we get for that one. For number 2, I started it, but I'll work on it with you guys when you're doing these ones. So the first thing I did was I rewrote it out, didn't necessarily need to, but the biggest thing is pulling this half out. So I'll get an r squared, and this one's going to become a negative 12r. So now I need to figure out what my next one is. So I have r squared minus 6r minus 6r, and this is all in my box. So we're going to have r and r times negative 6, we have us negative 6r, r times negative 6, will give us negative 6r. So the negative 6 times negative 6 is going to be 36. So on the inside here, we're going to add 36. Actually, got a little bit ahead of myself like last time. The thing I do over here is multiply each side by 2 or divide by a half to get rid of it. Get rid of this half out front. So r squared minus 12r equals 4. So then the next thing, like I said, you can add 36. If you add 36 to this side, you need to do it to the other. So we're going to get 40 equals, and with r squared, or this factored out is going to be r minus 6 squared. So then you'll take the square root of each side, and you'll end up getting r minus 6, and that's going to equal plus or minus the square root of 40. So then the last thing to do is add 6 to each side. R equals plus or minus square root of 40 plus 6. And then that would be your answer for that one. Yeah. So the next one here, we're going to look at, so again, we already have our number off to the side. We're going to go there. So the thing we really need to do is pull out this 2. So we have 2, that's going to be p squared, divide that by 2, plus 4p, and that's going to equal 7. So immediately, I just divide this over. So you get p squared plus 4p, that's going to equal 7 over 2. So then the next thing we have here is finding the extra term, finding the next term. So we set up our box. We have p squared plus 2p, 2p. So we're going to end up getting p and p to equal p squared. P times 2 will give us 2p. P times 2 will give us 2p. And then we'll multiply these two together to get the term that we need to add. So it's 4. So p squared plus 4p plus 4, that's going to equal 7 over 2 plus 4. So then we're going to factor this out. So on this one, our factors are p plus 2. So p plus 2, it's going to be squared. That'll equal, and again, if we were to put this into a factor or a fraction, then this 4 can become 8 over 2. Again, you are free to work with the decimals. It'd be 3.5 plus 4, you get 7.5. That's the same as 15 over 2. So then the next step is square root each side. So you're going to get p plus 2, that's going to equal the square root plus or minus of 15 over 2. Again, if you wanted to write out 7.5, you could do that for that as well. Square root of 7.5. So subtract 2 from each side, and you get p equals plus or minus square root of 15 over 2 minus 2. And so that would be our answer for that one. Okay, on the last one here, we have this negative 5. So we want to actually add that negative 5 to the other side, just to get rid of it, so that we are just working with the terms we need to complete the square. So we'll add 5 to each side. So you're going to get 2y squared plus 3y equals 9. Okay, and then we need to pull out this 2. So we're going to get 2y squared plus, it's going to be 3 over 2y, and then that's going to equal 9. So again, I just immediately want to get rid of this. That way it's easier to work with. Divide by 2, divide by 2. Y squared plus 3 over 2y equals 9 over 2. If you want to write 4.5, that's fine. If you want to make that 1.5, that's fine as well. So the next step is going to be breaking this down and with the box. So we have y squared, half of 3 over 2, so 3 over 2 times 1 over 2, we're going to get 3 over 4. So 3 over 4 y, sorry, and then 3 over 4 y. So to get y squared, we're going to have y times y times 3/4 will give us 3/4 y. 3/4 times y will give us 3/4 y. To figure out this number here, we take 3 over 4 times 3 over 4. So this you'd multiply straight across. It's going to be 9 over 16. So we'd have 9 over 16. So that would be the number we need to add. So y squared plus 3 over 2y plus 9 over 16 equals 9 over 2 plus 9 over 16. Okay, so then on this side here, we'll break it down, we'll reduce it. The factors are y plus 3/4 squared, and that's going to equal, and so off to the side, this 9 over 2, if we multiply it by 4 over 4, or it would be actually, sorry, 8 over 8, we'll end up getting what this should be in 16. So on the bottom, we're going to get 16, and on the top, we'll get 72. So it's going to be 72 over 16 plus 9 over 16 to figure out what this is going to be, and that'll end up equaling 81 over 16. So for this one, it's actually going to be nicer. These are both easily square rooted. So this will work out nice for this one. Again, like I said, if you want to work with decimals, that's fine, but you do need to be aware of how to work with fractions. It's going to be something that's needed. So square root each side, you'll get y plus 3 over 4. That's going to equal, so the square root of 81 is 9, and the square root of 16 is going to be 4. So we have plus or minus 9 over 4. Last step, subtract 3/4 from each side. So for this one, we can actually figure out what our number is. We don't have to use any irrational numbers. So it's going to equal, we'll do the first one with a positive 9 over 4 minus 3 over 4. So when we do that, we're going to subtract the tops. So we get 6 over 4. That's the same as 3 over 2. So that's one of our answers. The other one is going to be when it's 9 over 4 is negative, so minus 3 over 4. That's going to end up equaling 12 over 4. Or that's also going to equal negative, and that'll also equal negative 3. So with this, we can have negative 3 or 3 over 2. Both of them work for y. So when you're working with these, I know the fractions can be a lot. Like I said, it's fine if you use decimals, but sometimes it's going to work out nicer, kind of like here, where you stick with the fractions, you can get a nice answer, like we did right here. So that is all I have for 13. You're now applying what we learned in the last lesson and using it to solve. So if it didn't make sense as to why we're doing it now, hopefully it makes sense as to how it can help us to solve these problems. Because these ones up here, you're not going to find a nice factor for them. So that is all I've got for you for lesson 13.